Today we are going to continue looking at section 5.2, and we are going to be finding missing pieces of triangles. Okay, so we're going to round sides to the nearest hundredth. So once again, that's 2 decimal places, and then we will find angles to the nearest degree. So remember, thinking about our lovely phrase of SOHCAHTOA is going to be super important when we are solving these right triangles. I'm giving you a right triangle, so there should always be 3 things from the triangle that we already know, and then 3 things that we're trying to find. So if I'm looking at this first triangle, looks like the measure of angle A is given to us to be 36 degrees. Angle C is given to us, that's 90 degrees. The side AB is given to us to be a length of 8, and then I don't know anything else. All right, so that looks like angle B, the side BC, and the side AC are what we're trying to find. We can find the measure of angle B very quickly because remember, 3 angles of a triangle add up to 180, and since one of them is already 90, the 2 acute angles have to add up to 90. They're complementary. So I just have to take 90 minus 36, and that's going to get me the measure of angle B. So it looks like we have a 54-degree angle there. Okay, so then because angle B, I'm going to call that little b instead of using 2 letters, and then side A because it's across from angle A. So those are the 2 things that I want to find. So let's say we start with finding side A. Okay, I'm going to just use the angle that's already given to us in the picture, which is a 36-degree angle. If I'm thinking SOHCAHTOA, A is across, so it's opposite. 8 is the hypotenuse because it's across from the right angle. So opposite and hypotenuse, I'm going to use sine in order to find side A. So sine of 36 degrees is going to equal A over 8. Once again, make sure your calculator is in degree mode, but we will then just have to multiply both sides by 8 to get rid of the denominator, and then that got us A by itself. So then carefully type this into the calculator exactly how you see it there, rounding to the nearest hundredth, so 2 decimal places. Side A, which is really that BC length, is going to be 4.70. Okay, because the number after it is a 2, so it's not going to round the 0 up. All right, and good thing it's smaller than 8, because remember, 8's the hypotenuse. That should be the biggest side. So now let's find B. Once again, I'm going to use the 36-degree angle. B is adjacent. 8 is still the nice number given to us without any rounding, so that's the hypotenuse. Adjacent and hypotenuse is cosine this time. So the cosine of 36 degrees is going to equal then B divided by 8. So same process as what we did to find the other side. I just had to multiply both sides by 8 and then carefully type that in, round to 2 decimal places to get to the nearest hundredth, and it looks like this one would be 6.47. If you're not getting these values in your calculator, once again, make sure you're in degree mode or reach out to me and we can try to figure out why your calculator isn't getting you these values. Okay, let's take a look at this next one. Once again, these are all the pieces we want to find. We should be able to find 3 things right off the bat from the picture. So it looks like it's angle A, that's the 90-degree angle. It looks like the side that's across from A is 6. So that means side CT is 6. And then the side across from angle C is AT. That's given to us to be 4. Okay, so there's the 3 pieces. I'm going to find then the third missing side. So that's across from angle T. So I'm going to do then Pythagorean Theorem. Notice that 6 is the hypotenuse because it's across from the right angle. So I have to set it up as like T squared plus 4 squared to equal 6 squared. Okay, we want to solve for T. So that means that we'll have T squared plus 16 to equal 36. I'll subtract 16 from both sides. T squared is going to be 20. And then to get rid of a square, I'm going to take the square root. And once again, square root of 20, I want to round to 2 decimal places. If your calculator is just spitting out the reduced radical as 2 root 5, remember, hit the little arrow button, like the double arrows, right in above enter if that's your calculator has that, and it'll turn it into a decimal for you. And it needs to be smaller than 6, and luckily this one is. So to 2 decimal places looks like it's going to be 4.47. All right. So now I have that. I just need to find my angles. It doesn't matter which angle I find first. I think I'm just going to find angle C. Okay, so if I want to find angle C, the two sides that are given to us that didn't involve any rounding are the two numbers I'm going to use, which is 4 and 6. So with angle C, 4 is across, so that's opposite, and then 6 is the hypotenuse. So that means I want to use sine. So we want the sine of angle C to equal 4 divided by 6. Once again, I'm finding an angle, so I want to use that inverse button, and then I'm dividing 4 and 6. And I want to round to the nearest whole number. And so because it's 41.8, I'm going to round it up then, and angle C is a 42-degree angle. Once again, because we are dealing then with just trying to find the other angle, and we already know that the one acute angle is 42. To find angle T, I just have to take 90 minus 42. And that's going to give me my measure for angle T to be a 48-degree angle. And there are all my pieces. Okay, so pause the video and see if you can do this checkpoint problem. Okay, so hopefully these were the values that you got. So we should have gotten a 61-degree angle, a 29-degree angle, and then the other side, when we rounded to 2 decimal places, was 3.87. All right, once again, a reminder of our angle of elevation versus angle of depression. Okay, angle of elevation, you are lifting your eyes, so from straight ahead up. So it's going to be inside the triangle. And then angle of depression, you're looking straight ahead and you are lowering your eyes. Okay, so let's draw a picture with this right here. It says a diver is at the top of a diving platform, which is 20 feet high above the pool. Okay, so I'm going to start with a right triangle because that's what these problems are entailing. So we start with a right triangle. And it's saying that the platform is 20 feet high above the pool. Okay, so 20 feet high is going to be that vertical side. The diver is at the top, okay? Obviously, here is the diving board because the pool is down here. Okay, there's the pool. Okay, so he's at the top and he's looking down at his coach on the side of the pool. So remember, here's the line of sight. It's always a horizontal line. He's looking down. This is my angle of depression. It's telling me that it's 26 degrees. We want to know what is the distance from the coach to the base of the platform. So if the coach is down here on the other side of the pool, here is then the base of the platform. The base is always on the bottom. So this, I'm going to call it X. That bottom side of the triangle is my unknown. Okay, so there's my diagram. Remember, I talked about the facts that this angle of depression, which normally starts outside of the triangle, is going to be then congruent to this angle down here because these are alternate interior angles. And essentially, this is technically your angle of elevation if you were talking about it in the perspective of the coach looking up at his student. So there we go. There is my picture. Now I can deal with just what's inside the triangle and I can solve. So thinking about SOHCAHTOA, 20 is across or opposite from that angle 26 down at the bottom, and X is the side that we want to find. It's a leg, so that means we're using tangent because hypotenuse is not being used. So the tangent of 26 degrees is going to equal 20 divided by X. So I'll have to get rid of the division by multiplying both sides by X. But then we don't have X by itself. To get X by itself, I need to divide by the tangent. So your calculator, once again, should already be in degree mode. 20 divided by the tangent of 26 degrees. It says round to the nearest hundredth. So notice that then the distance that we get should be 41.01 because it's 006. The 6 is rounding that 0 up. So then what are we talking? We're talking feet. So I want to put my units as well. So there's my answer. Okay, here's another one. It says an access ramp rises 3.2 feet over a distance of 30 feet. What is the angle of elevation? Okay, so once again, I'm going to sketch a picture of a triangle, more specifically of a right triangle. Okay, we're talking about a ramp that is rising 3.2 feet. Okay, so rising means we're going vertical. So 3.2 feet is going to be the height, but the ramp itself is 30 feet. So hopefully you're thinking about, okay, well, what does a ramp do? A ramp is an incline where, you're avoiding stairs. So this right here, that is going to be the 30. If they're asking what the angle of elevation is, that is going to be the angle that is down inside the triangle. So there is my angle. Okay, notice that the picture that we have sketched, the side that's opposite and the hypotenuse are in the triangle. So opposite and hypotenuse means we're using sine. So the sine of theta equals 3.2 over 30. So once again, in our calculators, we need to do the inverse button in order to actually get a degree. You're once again should be in degree mode. So second sine, 3.2 divided by 30. Okay, angle of elevation, let's round to the nearest whole number. And so we should be getting an angle of 6 degrees. And hopefully that makes sense. When you're thinking about a ramp, you're not going to want a really steep incline because you're thinking about people with like wheelchairs and that kind of thing. They're not going to want to go, more horizontally going up rather than vertically going up. So you want a really small number there. All right, here's a checkpoint problem. It says a cable from the top of a 100-foot telephone tower makes 50 degrees with the ground. How long is the cable round to the nearest 10th? Okay, so pause the video, try this. All right, so we're talking about a telephone tower. So that's going to be the vertical side of my triangle. So that's the 100. We're talking about then the cable from the top of the tower going to the ground. Well, that's going to have to then be that hypotenuse, okay? Because the cable's not going to be lying straight on the ground. Okay, 50 degrees with the ground means the 50 is inside the triangle. So once again, we're given the opposite and hypotenuse, so we're using sine. So nearest 10th, remember, is going to be 1 decimal place. So 130.5 feet is going to be the answer.